We'll discuss about some additional thing that will be helpful to understand noise in analog communication. Firstly, we'll discuss about joint probability density function. We have written explicitly in the notes. You can follow these notes or from Bifilati. I am just telling about the final solutions. Joint probability density function is given by this expression that it is the second derivative of the cumulative density function, and the volume calculated to get the probability of x lying between x to x plus del x and y lying to y to del y. And the marginal probability density function has also been shown. And if it is conditional density function, that means both are depends have some condition on the another occurrence, then what will be the probability density function in that case has also been shown. And finally, we have concluded that if there are two independent random variables, their joint probability density function can be obtained by the individual probability density function multiplication. Now we have elaborated a Rayleigh density function that we just given the expression in previous. Here we have shown that how by taking two Gaussian random variable we can have a Rayleigh density function, and you can easily see from the figure 1 and figure 2, and also from this figure where we have mapped xy coordinate to r theta or polar coordinate, where r is given by root over x square plus y square, and if theta is considered to be random variable, tan inverse y by x. And we have shown also the calculation how to get the Rayleigh density function, and we have obtained r by sigma square e to the power minus r square by 2 sigma square, where r is root over xy, x square plus y square, and similarly we can also derive this expression. Now we have discussed previously about bandpass Gaussian bandpass random process. Now for the sake of noise, we will also discuss about bandpass white Gaussian random process, and using the quadratic representation we have shown how they can be represented and how their noise power in quadrature can be calculated. I think you can easily understand, because several times we have discussed with such type of cases. And we have also considered the sinusoidal signal when it is mixed with some noise, and when the noise is Gaussian in nature, white Gaussian in nature, and here also we will consider noise in quadrature, so that we can consider two Gaussian, and we will see that in that way, when we are mixing a sinusoidal signal in noise, how we are getting the Rayleigh density function. This also helps you to understand the basic concept of Rayleigh density function. It's a total derivation or a whole derivation you can get from the journal paper mathematical analysis, or from I don't know, this is book. I think it will maybe be a book or journal, whatever maybe. It is you can see from the Rice mathematical analysis of random noise. You can see, and here we have in the figure we have shown that when a by sigma becomes 0, the Rayleigh density function becomes a Rayleigh density function. So with this basic knowledge, I think you can easily understand noise in AM and FM signal. The last part, that is TTM and FDM, as the name suggests, and you have also written in your assignments that TTM is time division multiplexing and FDM is frequency division multiplexing. In case of time division, total time is divided, and in how it is done is shown in figure. It is synchronized by rotary motion, that when this transmitter 1 is selected, this receiver 1 is also selected, and how they are handled considering the sampling rate has a brief calculation has also been shown. You can see it, and whenever you will study the digital communication, the actual diagram may be one of this method. In case of FDM, the total frequency is divided between the users, and separate frequency is fed from the frequency synthesizer, and then it is passed, and at the receiver we use band pass filter, demodulator followed by low pass filter to get corresponding message signals. And that's all for the communication. Here I want to point out two assignment questions that students differed in some cases. That one question is on the super heterodyne receiver. Whenever you have calculated the image frequency, mind it, the image frequency is the frequency under consideration of the RF signal that it is actually selecting as the RF station, and here we have the mixture, and here the IF frequency, and here from a local oscillator you are feeding the mixture. This is the RF frequency, this is local oscillator frequency, this is the IF frequency. So whenever you will calculate the image frequency of this RF frequency, that will be RF frequency plus twice into image frequency. Or if you consider local oscillator frequency, then it will be FLO plus A5. Okay, so be cautious about this. If you use RF frequency as calculation, then use this formula. If you use local oscillator frequency, then use this formula. Another question I want to tell, that a question was to justify that FM and PM are inseparable, or can be from FM we can go to PM or PM to FM. I tell you that you always mention the block diagram of how to get FM from PM and vice versa. That will complete your answer. Thank you.